Yes, sir.
So in today's class, we'll just have a glance what we studied in our yesterday's class, and then we will proceed with the next concept called as energy. So first of all, you remember in this chapter, like 2 days before, we studied what is work. So work is equals to formula. What work formula? Everybody, work or
No,
work
sir.
done is
If
equals
dot
to
S.
F dot
Yes, sir.
S, or we can say if the force is applied with inclination. So what is that?
F dot S dot cos theta.
Cos theta. So these are the two things we studied that. Now, next yesterday's class we studied that the rate of doing work. That is what we will say. Work done by
Work done by time.
work done by
Rate of
time is only we used to called as what? All of you power. So work done
power.
by power, work done by time is only called as power. So work done means I can write as a force into displacement by time. So I can write force into displacement by time, which is equals to something. What is that, everybody? Velocity.
Velocity.
That is what I can say. Power is equals to what, everybody? Force into velocity.
Velocity.
Force into velocity. So option is you must learn. This is very important. Your ninth class physics, your school physics, chapter number 4, it will come. So what we are studying is just everything for your school syllabus as well as next foundation also. So middle only one chapter is left. That is what gravitation. The two we people will discuss. Definitely. I will next after foundation, next chapter is gravitation only. So we'll go very deeper, even orbital velocities, everything we'll calculate it. Even the Chandrayaan 3 recently what launched, how they have been launched, all the things we'll calculate it even. Okay. So now we have studied this. Yeah, units of power. So what is the units of power we have studied yesterday? What is the SI unit of power, everybody? Watt. So 1 watt is equals to, what is that formula? 1 watt is
1 joule by second. 1 second.
1 joule per 1 second. So that is what we used to called as 1 watt. Understanding? So watt we have studied. And what is the commercial unit of power, everybody? Commercial unit. Commercial unit. I asked you even yesterday's. Shivani
HP.
told
HP.
HP.
Horsepower.
So, yeah, horsepower. 1 horsepower is equals to how many watts, everybody?
746 watts.
Watts. Understanding? 746 watts. And we will start, we have now next dimensional formula of power. Yesterday we have studied that. So what is the dimensional formula? Unless you speak, you people.
M power 1,
M power 1.
N power 1, L power 1,
Dimensional
T
formula of
power
power.
minus 2,
E
Very
power
good.
minus
power
3.
minus 3.
Dimensional formula of power. Power means we all people knows that work done by time. So work done means we all knows that force into displacement divided by time. So we all knows that force. So what is the force? Actually, force into this one I can write velocity. So what is the force dimensions, everybody? M power 1. Speak loudly. M power 1.
M power 1,
Power.
L power 1,
L
T
power
power
1, T
minus 2.
power minus 2 into velocity. So velocity means meter per second. So meter means L power 1 and
L power
second means
1.
T power 1. So it will turns into up. What will become, Mr. Sam? It will turns into what? M power 1,
M power 1.
T
L
power
power
2,
2.
Power
T
1.
T
power
power minus 3.
minus 3. So this is the dimensional formula of power. Everybody, I hope everybody learned. Anybody having any doubt, you can ask me. Those who joined late, you have to be very in time, very seriously you have to follow. So please make it till here. Any doubt, let me know. Mr. Darshan, join properly. That's all about it. Any doubt, guys? Please let me know. All of you understand? Hasini Sudhaka, Hasini, Mr. Lingesh. So this is what yesterday what we studied. Dimensional formula of power. Please learn very important. Dimensional formula of energy. Sorry, dimensional formula of force. The dimensional formula of force is M power 1, L power 1, T power minus 2. Always you have to be one step forward compared to your friends. That is what is expecting. So M power 1, L power 2, T power minus 3. So that is what is the dimensional formula of what? All of you? Dimensional formula of power. So now, in our today's class, we are going to study the next concept is called as, what is that called, everybody? All of you? Energy.
Energy.
So now, let us discuss what is energy. Now, all of you, let make it everybody. So when we do not eat food, for example, I hold you somewhere where no food is served for you for 2 days. What you people will feel? I want to know. Everybody? Do you people will work I will ask you, for example, 2 days there is no food, and I will ask you to study. Will you people will do the work, or I will ask you to like cut something or break something? Now, will you able to do the work, everybody?
No, sir.
No.
No,
So that is what it is like energy. So when you will get a capacity or ability to do the work, only when you eat the food. Am I right or wrong, everybody? When you eat the food, you will get a
Yes,
energy.
sir.
Understanding? You will get the capacity to do to finish the work. Suppose I'll ask you to break the wood. For example, you can say, or I will say there is a small car. I'll ask you to push the car. Let me take now. I'll ask you to push the car. Now I never serve the food for 2 days for you people. So that is the work done. So what is your work? You have to displace this car from this to here. This is what is our target. Now that is the target I allotted you. There is no food is served for you. Now if when you get a capacity to finish your work, only when you have what? Everybody, food. Am I right or wrong? Yes. So when I eat the food, understanding? When I eat the food, then only I'll get a capacity to finish the work. Am I right or wrong, everybody? Yes, please. All of you.
Yes, sir.
Yes, sir.
That capacity or ability to do the work is only called as what we is to call, everybody? Who is to call as?
Energy.
Understanding, Amma? So the word energy is actually derived from the Greek word called as, from the Greek word. What is the word? From the Greek word called as energia, meaning the word which is actually derived from the Greek word. What do you mean by energia? Means in work. What is the meaning of energia, everybody? In
Inward.
Okay. So that is the word it is derived. So energy means what, everybody? Definition, write it. A capacity or ability to do the work. Ability to do what, everybody? A capacity or ability to do the work is only called as what? All of you? Energy. Okay. So now let us understand what is this energy. And if you notice it here, what is the SI unit of energy? Sorry, work. Anybody can tell? What is the SI unit of work we have done? Any one of you? Of course, work means you people can write force into displacement. You have written work. What is the unit of work? Anyone?
Joules.
That is what you can
Joule.
write Newton meter. Am I right or wrong, everybody?
Yes, sir.
Yes, please. But keep it in mind, work done unit is joules only. But if it is work, you can write in place of joule. You can write what, everybody? In place of joule, you can write what, guys?
Newton and 2 meters.
Understand?
Newton.
Now, remember the units of work and energy both are same. So that is what is that actually? Joules. Okay.
Joule.
So units of work and units of energy both are same. But if energy, 1 joule is not 1 joule, you cannot write. You cannot write in place of energy Newton meter. Understand, Mari? Sanjay? Tingesh? That is very important. Understanding? If it is a work done in place of joule, you can write what, guys? In place of joule, you can write what? Everybody? Newton meter. But if it is energy, in place of joule, you cannot write Newton meter. Do you understand, everybody, what I am saying? Agalya, Shivani? That is only the difference between energy and work. Okay. So in place of work, you can write Newton meter in place of joule. But in energy,
So that's, sir, in the sense work done.
yes, Mari. Work or work done. In place of work done, Mari, suppose if I say work done is equals to 10 joules. So you can write it 10 Newton meter. Understand, Mari? Example. But
Yes, sir.
if I say, for example, energy is 10 joules, you cannot write 10 Newton meter. Do you understand? It is wrong. Okay, wa? Clear?
Yes, sir.
Newton meter, you can be replaced by joules only for the work done, not for energy. Is it okay, guys? Everybody clear? Understand or not? All of you?
Yes, sir.
Yes? That
Yes,
is-
sir.
So anybody having any doubt, you ask me. Kavya, understand, Kavya? Now, let us discuss what are the examples of energy. So, what the examples you people can see in our daily life? Examples of energy. Okay. So, what happened to Gokul and the Tarashini? Always laughs and laughs. So, if anybody having doubt, please let me know. So, let me make some of the examples of energy. So, if you all of you observe very carefully, so there is a few examples here, which is more than enough for us for studying. So, these are the examples of energy. So, which you all people can see that one by one. So, later you people can write it. So, totally 8 examples are there. So, first one, sound energy. So, you might be studied in even 8th class. Sound is produced by the body only by the something. Anybody can tell what is that? Everybody?
Vocal.
By the
Vocal.
vocal, not our body. Am I asking our body? I'm not asking our body. Generally, sound is produced by any body. By what? Anybody can tell? By a word called as
Medium.
yes,
Medium.
medium illa mari. Of course, sound
Medium.
needs medium for propagation. Sound needs medium for
Vibration.
propagation. Yes, Nivedan said correctly. So, what is the word? We have to use it, everybody? Vibration. So, every vibrating body only will produce us the what? Sound. Am I right or wrong? All of you? Mr. Gokul Ras, late, very late and joining late. This is not the way to join. How they are joining, check it. According to that, you join. How your friends given numbers. Mr. Silesh also. So, all of you remember, vibrating bodies only will make sound energy, whatever the body. And sound energy, if it wants to propagate, always it needs something. Anybody can tell what it needs? It needs
Medium.
understanding? It needs medium like air, water, wood, metal, or something. Understand, Alfin? So that is only is to called as what is to call sound energy. So first one, what is the first one, everybody? Sound energy is produced when an object what? Everybody? When an object vibrates.
Vibrate.
And the sound vibration causes waves of pressure that travel through a medium. What is that medium? Such as air, water, wood, and metal. So for sound energy, propagation of sound energy, medium is necessary. Medium is necessary for what purpose? For propagation of what energy, guys? Propagation of, please speak, sound energy. Okay, ma? For light, light can travel with or without medium. Next, heat produced in a pressure cooker due to the building up of pressure can lift the weight placed on the lid upwards. So the heat which is producing, if you take the pressure cooker, you can notice it, all of you. So there is a lid which is present, the whistle sound will come. So the gas which is coming up, you can see steam. So that is what heat energy. So why heat energy is producing? Because of the pressure which is increasing inside. So pressure rises, temperature also rises. That is what second, heat energy. Next, at the microscopic and atomic level, the light incident on certain metallic surfaces can cause emission of what? Everybody, this is all little high level energies. So please remember. So at microscopic or atomic level, when a light incident on a certain metallic surfaces, what will happen, everybody? It can cause emission of something. What is that speak here? Emission of electrons from the
Electrons from,
surface.
sir.
So light is capable of doing work, and it is a form of what? Light is a form of capable of doing work, and it is a form of what? It is a form of
Energy.
energy. So what is that, you know, everybody? So this is most important one. Of course, you will study in our 11th class also, it is form of energy. So when any kind of light falls on a metallic surfaces, it will try to emit emission of electrons from the surface. Means electrons will start releasing. That is what electrons means, Terima. Every atom is made up of 3 subatomic particles. What is that, guys? 7th class you might be studied. Center nucleus is present. So nucleus, what is containing? They contain something. What is that? Protons and Protons and
Protons.
neutrons, and electrons are revolving in orbits. That is what we used to call as. What we used to call everybody? Negative charge. They are called as electrons.
Electron.
So please make it that. Any doubt? Anybody can ask me. Clear, everybody? Mr. Gokul Raj, can you hear me? I'm calling you, but no response. Late always. All of you understand, Amma? The format which is given you,
Yes, sir.
only you must join, Mr. Gokul Raj. I modified your name. According to that, only you join. Okay, from tomorrow. Very serious. Next, a magnet placed near toy car. We all knows that. A magnet placed near toy car made of some magnetic material like iron can attract it and make it move. What is the energy here? Because of magnet energy, magnetic energy. Understanding? So the work can be done by the magnetism. So this forms an energy. What is that energy called as, everybody?
Magnetic energy.
Magnetic energy. Next, electricity flowing through the conductors can make the machines to move. And this is called as what energy?
Electric energy.
Understanding? All of you? Now electric bus, electric car, everything is coming. How they are getting the energy? From electricity only. Am I right or wrong? For movement, they are getting the energy from the electricity. Right or wrong, guys? Everybody speak.
Yes, sir.
Yes.
Yes,
So
sir.
that is also a form of energy. So we can say electricity is also a form of energy. Next, energy possessed by bodies on account of their position or motion. This is what very important one. Keep it in mind. Due to position, now I will enter and later I will teach you. We are going to study that. The energy possessed by the body due to the position we used to call as potential energy, PE. What energy, everybody? Potential energy.
Potential energy.
Due to the motion, the energy possessed by the body is called as kinetic energy. What is that? Kinetic energy. So that is what the combined potential energy plus kinetic energy combined, then only we used to call that name. What is the name of the energy, everybody? Yes, please.
Mechanical energy.
Mechanical energy. Okay. Now, suppose if the water stored in the reservoir or dam, what energy? Position. It is stored. So what energy they will possess? Everybody. It is stored. What energy it will possess? Stored. Position, guys. Water is stored in the reservoir. It is the
Potential.
position. So potential energy. Water is started flowing in a capable of doing work.
Kinetic energy.
Kinetic energy. So that is what we used to call mechanical energy. Now keep it in mind. For example, you are standing in our terrace. You are standing in our terrace. You are possessing. You are at this position. So what is energy you are possessing? Everybody, who is that making sound? Yes, Kishore. You are standing in the position. So that what energy you are possessing now? You are possessing potential energy. When you jump from there, you will start moving. So by that time, you are possessing what energy? Due to the motion.
Kinetic
Everybody.
energy.
Kinetic energy. Okay. So that is what. See, this both potential energy plus kinetic energy together we used to call as what? All of you. We used to call as
Mechanical energy.
mechanical energy. So now, if I release the water from the dam, the water will start flowing. Is that water can do the work or not? Anybody can tell me? It can do the work. It can carry many objects. It can flow away many objects. Am I right or wrong? All of you?
Yes, sir.
Yeah, it can be even flooded. So that is the flowing water is capable of doing work. It can do. It can break the things. It can damage the things. It can carry many objects with such a big flow. So that is what it can doing work. It is a capable of doing work, and that is why we can say it is an example of what? Everybody. Stored water and flowing water is an example of what? Everybody. It is example of mechanical energy.
Mechanical energy.
Next, the energy possessed by the atoms of elements or molecules of compounds, such that it is released and capable of doing some work with a chemical reaction. So that is why that is called as, what is to call? Everybody, chemical energy. Every chemical reaction, please remember everybody, every chemical reaction is taking place with the help of energy only. Am I right or wrong, everybody? Please respond. Takes place by energy possessing. So that is why the energy possessed, okay, is only called as, what energy we used to called as? All of you.
Chemical energy.
Chemical energy. I will send you Laksha. You just focus, first learn. So the energy possessed by the chemical reaction. What energy we used to call everybody? Chemical energy. Understanding, Amma?
Chemical energy.
Next, nuclears. Nuclear power stations, you might be heard. The energy released during the nuclear reactions. Nuclear reactions. It is called as what? Nuclear energy. Nuclear reactors, power stations. Nuclear reactors, the energy released by them, we used to call as what? Everybody? Nuclear energy. So now presently all over the world, nuclear energy is one of the powerful energy. Most dangerous energy is this one, nuclear energy, which is possessed. Bomb blastings and all you can see. The energy released during these nuclear reactions is only called as nuclear energy. Sir, what is the nuclear reactions? Two things we can say. One is fusion and another one is fission. Okay, I will teach you that. Okay, when we are studying the types of energies and all, we will study that. Okay, so nuclear fission and nuclear fusion. Okay, so that both actually nuclear reactions. So the energy possessed during this time we used to call as, what we used to call everybody? All of you? Nuclear energy. So these are the examples of energy, so which we will see in our daily life. I hope everybody understand what is that. I will send you later, you can note it. So these many examples you can make it for energy possessed by in our surroundings. What examples of energy and everything. So every energy is doing the work. Will you all see that or not? Everybody, all of you. Every energy will do some work. Am I right or wrong? All of you.
Yes,
Yes
sir.
or no? So that is
Yes,
what.
sir.
So that is why we will say, what do you mean by energy? Definition. Capacity or everybody? Ability.
Capacity or
Ability to
ability to do.
Okay. So that is what you have to remember. Write it. Next. Units of energy. Already we people knows. What are the units of energy? Yes, please.
1 joule.
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 1 joule இல்லம்மா 1 joule கிடையாதம்மா. Joule மட்டும்தான். சரியா? 1 joule is not the answer. Joule is the unit of energy. Okay, guys? All of you? Yes, please.
Yes, sir.
Yeah. So now, first let us write CGS unit. So what is the CGS unit you are expecting for energy? Anybody? Erg. Okay. And the SI unit is joule.
Joule.
Okay. So what is the CGS unit of energy? Everybody? Yes, please.
Here.
Erg. Okay. And SI unit of energy is what? Everybody?
Joule.
Joule.
Okay, please remember.
Joule.
Okay, ma. Already units of work. CGS unit of work also how much? Virami, we cannot do any work without energy. Understanding? So if a work is done by anywhere means definitely some energy is possessing there. Understanding, Amma?
Yes, sir.
So what is the CGS unit of work, guys? Check your notebooks. Yesterday we have done day before yesterday. Work also, what is the CGS unit? We have done it. Erg only. Am I right? 1 erg is equals to, we have written 1 dyne into 1.
Gram centimeter per second square.
Yes, same way. One again. What is the SI unit of work? Everybody, joule. Am I right or wrong? So 1 joule is equals to what you have written?
Kilogram per
Kilogram
kilogram meter per
1
second
Newton
square.
into 1 meter. Am I right, Mare? I'm just normally
Yes, sir.
asking. So same. But you cannot write this one for energies. So what is the CGS unit of energy? Everybody? CGS unit of
Yeah.
energy. Yes, please.
One
Erg.
Yes, erg. And what is the SI unit of energy? Joule.
joules.
Joule.
And some other units. Some other units of energy. So very important one. So some are commercial unit, some are normal. So what is the commercial and normal unit is watt hour. What is that? All of you? Watt hour. Sir, how sir watt hour? Shall we start now? How watt hour will come? Everybody? Yes, please. So very simple. Okay. So we all knows that power means, anybody can tell me what is the formula we have done? Power means what?
Erg divided by 7.
Yertha. Work
Erg.
divided by
Work
time.
divided by time.
Work, the capacity to do the work only called as what? Everybody. The capacity to do the work
Energy.
only called as what?
Energy.
Energy. So that's all.
Energy.
So can I write power means E by T, everybody? From that, energy is equals to power into time. Can I write, Mari? Mr. Lingesh? Yes, please.
Yes, sir.
Speak loudly. That's all. So energy means I can say joule. So joule is equals to power. What is the unit of power? Watt. Watt into time means second. So that watt second or watt hour I can write. So that is only the another unit of energy. Everybody clear? All of you? Watt second, or I can say watt hour. Is it okay, guys? Basically, watt means seconds, we'll say. Kilowatt means what we'll say, everybody? Kilowatt
Hours.
means we will say what? Hours. Okay? Bigger units. Understanding, guys? Everybody? Watt hours, we can say
Yes, sir.
one is kilowatt hours. 1 kilowatt equals to how many watts? I want to know from you people. 1 kilowatt is equals to how many watts? Yesterday I have taught you. 1 kilowatt is equals to how many watts? Check it, everybody. 1000 watts. We have written or not? Mr. Nivedan?
Yes,
What
sir.
people are doing, I don't know. Okay, that is what. So please write it. Next, another unit is very important. Nobody knows this one. Only you people are going to learn. Electron volt. What is that? Another unit of energy, everybody? Electron volt. And last one is calorie. Now, if you eat the chocolate, anybody having chocolate in our fridge and all, go and check it. The energy is mentioned in what? If you eat the chocolate, this much energy will come. Check and tell me, anybody having chocolate? I want to know what they're mentioning. What is the unit they mention? All of you. And yesterday I have taught you, erg is equals to how many joules? 1 joule is equals to how many ergs? 1 joule is equals to how many ergs? 1 joule is equals to how many ergs, guys? Check your notebooks. Yesterday we have done.
Yeah, 1 joule is equal to
1 joule is equals to 10 power 7 ergs. Correct, Amma? And
Yes, sir.
one erg is equals to 10 power minus 7 joules. We have written or not? All of you. Learn it. That is only necessary for us. Understanding? And tell me now, yesterday, what is the chocolate? Okay, Nivedan is saying. What, Nivedan? Your chocolate capacity is 521 calories. Yes? Lingesh, tell me, what is
Yes,
your
sir.
chocolate mentioning? Your home chocolate. What is mentioning? Kilojoule per gram. Very good. Others chocolate, check it, Amma. Your refrigerator, no chocolate is there. Very, very bad it is. Or else Maggie,
There
some.
is only energy represented, sir.
Yes, Mari. Energy, how many joules, Mari? Check it, Mari. They will be
Sir,
giving.
it is given in kilojoules only, sir.
Yeah, kilojoule.
1452
1000?
kilojoules.
1000.
452.
Oh,
1452.
1452. So 1452 kilojoules. For what? Which chocolate?
Sir, Haribo, sir.
Oh, okay. So that calories, Nivedan, what is your chocolate? Okay, girls, no chocolate. Very bad. Yeah, Shivani. Shivani is saying 443.
2002.
Yeah, 443 point kilocalories. And Lingesh is saying 250 kilocalories. Very good, Lingesh. Others, Teriyada, Pakranga, idellame enna? Energy. So if you eat, see that some chocolates kilojoules, some chocolates calories, some chocolates they'll mention in some other thing. So this all are the what? Units of what? Everybody. Units of? Yes, please. Energy.
Work.
Energy. So means if you dairy milk. Okay, Nivedan is saying dairy milk chocolate is 2232 kilojoules. Which is dairy milk, right? Perusu dairy milk. Yes, very big. So calories also we can say kilocalories. Okay, ma? All of you remember that. So kilocalories also we can say. So when we eat a small chocolate also, check it everybody, how much energy you'll get it. If you're having that what is a chocolate? That peanuts and all will be there. Very costly chocolate. Enadi? Small thing, but very expensive.
Snickers.
Huh?
Snickers.
Snickers. Snickers, you can see that. I think Alfin is having. Alfin, no chocolate. You can check the Snickers. Very high energy will be there. All of you see that. Okay, everybody? Yes? So these all are the what? Energy units. Now, so you all people know these many units we have, other units of energy. So galaxy, 196 kilocalorie, 36 grams. Okay, Abhirami. So this is what the units of energy, some other units of energy. So let us discuss what is this kilowatt hours and watt hours and all. So what 1 kilowatt hour is equals to how many joules? Let us check it first. How to write kilowatt? Check it, everybody. Small k, capital W, small h. What is the meaning of this one, everybody? Kilowatt hour. What is that, everyone?
Kilowatt hour.
Kilowatt hour. Small k, capital W, h. So 1 kilowatt hour is equals to dash joules. Because we all people knows joules is the SI unit of what? Joules is the SI unit of what?
Work.
Yeah.
Work and energy.
Mari. Now we are speaking about energy. And kilowatt hours is the commercial unit of energy. Another commercial unit of energy. Okay, everybody, please respond. All of you. Now, immediately, if your parents are near, your grandparents are near, ask them what is the how much power you consumed in our house last month? How much electricity? How many? Ask them. They'll say what and tell me. At least one or two should respond. Ask them and tell me what is the power consumption by our house? How many? What they're using? Correctly tell me the word, what they're saying. It's not actually power consumption. It is actually energy consumption. But we will use a word called as power is a common word. It's not the power. Energy consumed.
Energy.
Energy consumed by your house for last month. Yeah. Laksha is saying that 330 watts. 330 watts is very small. It's wrong. It is wrong answer. Watts is the unit of power, not energy. Ask your father correctly. How many units of energy is consumed by our house? Electricity. Ask them. They will say something. If you say watts, it is wrong. It is power. Energy, I am asking. Electricity, energy, electrical energy consumption. Anybody said 100 units, 150 units, 500 units, 300 units like that? At least any one of you? Nobody, parents are saying. My house last 2 months electric bill is 499 units. Approximately 500 units I got it. So what do you mean by that, guys? That units means? Yeah, Abhiram is saying 1 or 2 units. Any other? Lingesh, approximately 409 kilowatt hours. Very good, Lingesh. I think your father knows. So basically, we won't use even kilowatt hours. We will use in our daily language. What is the word we'll use it for energy? Everybody? Units, electricity mainly. So 1 unit is equals to 1 kilowatt hour. 1 unit is equals to how many hours? Everybody?
1 kilowatt hour.
1 kilowatt hour. So if I say 499 units means how many units my house is consumed? Yes, please. 499 kilowatt hours. Now Lakshanya house father is saying 550 units. Means how many units they consume? What is the energy they consume? 550 units means how much energy they consume? 550
kilowatt hours.
Kilowatt hours. That is what it is. So our commercial language, general language, we will use it as a power, electricity, this and all. But actually it is not the power. Actually what it is? Energy, electrical energy consumed. Electrical energy consumed by our house. That is what? Commercial unit of energy, kilowatt hour. So you ask your parents after that also. They will say in the form of units. So 1 unit equals to how many kilowatt hours? 1 kilowatt hour. Okay. So now let us see. Can I write this one as 1 kilo into 1 hour? Am I right or wrong? 1 kilowatt into 1 hour. Right or wrong? Everybody.
Yes, sir.
1 kilowatt means how many watts, guys? 1 kilowatt means how many watts? Today also I told you. 1000 watts into 1 hour is equals to how many seconds? Anybody?
60 seconds.
Three.
God.
3,600
Minutes.
1 hour is equals to 60 into 60 seconds. Okay, Mari? Be
Yes,
very
sir.
careful. So 3600 seconds. Multiply it and tell me how much it is, all of you. 36 into 1, 36. 3 zeros plus 2 zeros, 5 zeros. Vairam school has any understanding? Princi, watt into second. Am I right or wrong? All of you? Now this one, can I write it as a 36 into 10 power 5 watt second? Any problem for anybody? Girls? Boys? Agalya, no
No, sir.
response. Shivani and all. So now 36, can I write it as a Mari? Observe 3 by 6 into 10. Sorry, 3.6 into 10. Can I write it? Sorry, 3.6 illa. Yeah, 3.6 into 10, not by 10. 36 can I write as a 3.6 into 10? Yes, please.
Yes, sir.
Yes, so the totally answer is how much? 3.6 into 10 power 6 watt second. Can you tell me what is 1 joule is equals to? Energy. Power formula. Power is equals to energy by time. Power is equals to watt. So energy is equals to joule by second. Now I want 1 joule. 1 joule is equals to how many watt second, guys? 1 watt into 1 second. Am I right, all of you?
Yes, sir.
Yes. So can I replace in place of watt second? What I can replace? What I can replace? Joules. Okay. So 1 kilowatt hour means how many joules, guys? Everybody speak. 1 kilowatt hour means how many joules? Keep it in mind, small k, capital W.